Hello, dear students. I'm glad to meet you at our course. Today we are going to talk about glass as a structural material. Let's start. Glass is a versatile material. Being an open hard substance created by giving heat to sand or quartz, glass forms an inorganic, transparent, or translucent material which can be molded into any shape. It is a mixture of raw materials like silica, sodium potassium carbonate, lime or lead oxide, manganese oxide, which are grounded, sieved, and mixed in specific proportion and melted in the furnace. It makes an excellent medium possessing diversified uses and properties. The history of glass goes centuries back, where we find the reference of naturally occurring glass during Stone Age period. Glass was then used for making weapons. Later, with passage of time, it was used for making vessels, mosaic tiles, decorative objects, light picking, etc. After all, not only does glass render a sleek and sophisticated charm to a space, but it is also designed to be highly functional. Fulfilling the modern consumer's modern and varied requirements, glass solutions are the top pick in the current day and age, and the precursor to all modern-day glass solutions is float glass. Float glass is a super smooth, distortion-free glass which is used for designing other glass items such as laminated glass, heat-toughened glass, and so on. With a natural greenish hue and translucent nature, it is capable of transmitting about 87% of the incident light, and unlike sheet glass, float glass provides users with a crystal clear view. Float glass owes its unique name to the process by which it is manufactured, wherein the molten glass is introduced into a bath of molten tin, causing the glass to float freely. Glass invention dating back to at least 3,600 years, but float glass came into existence in the late 19th century. In earlier centuries, glass was made through the blowing and disc method. Since the glass was simply used for creating windows in the old days, window glass or other flat glass were produced from large discs of crown glass or by blowing glass bottles. The discs were usually cut into pieces, flattened together, and cut out to create the window panes from the large surface. But between 1953 and 1957, Sir Alastair Pilkington revealed the idea of manufacturing float glass to the world. And although Henry Bessemer, a United Kingdom engineer, patented the earliest advances in automated glass manufacturing, it was Sir Pilkington who perfected the production of float glass. While the original process of producing float glass by Bessemer used a continuous ribbon of flat glass by forming the ribbon between rollers, the Pilkington method developed the ribbon of float glass using a molten tin in which molten glass would flow unhindered under the influence of gravity. Bessemer's version was an expensive process, but with the efficiency of the Pilkington method, Sir Alastair was able to achieve profitable full-scale sales of float glass by 1960. The ultimate strength of glass is related to the rate at which it is cooled. There are four main types or strengths of glass. Annealed glass. Annealed glass is used as a base product to form more advanced glass types. Heat-strengthened glass. The heat strengthening process increases the mechanical and thermal strength of annealed glass, making it twice as tough as annealed glass. Tempered or toughened glass. This is the most common type of glass used in balustrades or similar structural applications. Laminated glass. Any one of the above types of glass can be laminated. The most commonly used finished product is two sheets of toughened glass laminated together with a 1.52 mm thick interlayer. Considering the outlook and need for energy-efficient buildings, Research has been carried out on glass to develop the properties such as refractive index, reflection loss, thermal transmittance, visible light transmittance, infrared transmittance, ultraviolet transmittance, chemical resistance. Just like any other building material, glass has its share of advantages and disadvantages. Advantages of glass are transparency. Glass allows light to pass through it so that the objects behind the glass are visible clearly. Thus, it saves energy and reduces electricity bills. Dust-proof and waterproof. Glass has a smooth, glossy surface, so it is dust-proof and can be cleaned efficiently. Thus, it is mostly preferred in the areas often clad with dust and sand in the air. Color availability. Glass is available in wide range of colors, and when we combine the glass sheet in laminated or insulated units, it changes in color and appearance. Aesthetically appealing. Glass can make the structure look more stunning, sophisticated, and adds beauty to the building. Glass can give a complete aesthetical look to the whole structure. Recyclable. Glass is 100% recyclable and it does not degrade during the recycling process. Hence, it can be recycled repeatedly without compromising on quality or purity. Sustainable material. Glass is a sustainable material, fully recyclable material, which provides great environmental benefits such as contributing to mitigating climate change and saving precious natural resources. UV stable. Glass is not affected by ultraviolet radiation and hence cracks. Discoloration or disintegration will not occur. Weather and rust resistant. Glass is fully weather resistant. It can withstand the effects of the wind, rain, or the sun and can retain its appearance and integrity in most of the given conditions. Additionally, glass does not rust. Disadvantages of glass are cost. Manufacturing of glass is a highly energy-consuming process due to high temperatures required for processing the raw materials. Using glass in a building enhances the cost of security and privacy because of the transparency that it offers. Brittleness. Glass is a stiff, rigid, and a brittle material. When it is subjected to stress, it breaks without significant strain. Broken pieces of glass may be sharp, and chances of injury are very high. Impact resistant. Glass is less impact resistant, so the capability of the glass to withstand an immediately applied load is very poor. Thank you for your attention, dear students. Next time we are going to talk about plastic for construction. See you next time. Goodbye.